let's do it. We got engine performance 2 test 1517. And the sensor that must be warmed and functioning before the engine management computer will go into closed loop is the A, ECT sensor, B, MAP sensor, C, baro sensor, or D, O2 sensor.
Okay.
You guys know it's, well, you are thinking in the right direction, but the oxygen sensor has got to be warmed up and working. The fuel system is not going to go into closed loop until it sees the oxygen sensor is actually functioning. And so there's the right answer for that one. You're going to have oxygen sensors. Now the voltage output of a zirconia oxygen sensor when the exhaust stream is lean, which would be less oxygen, is what? Relatively high, close to 1 volt, about in the middle of the voltage range. Relatively low, close to 0, either A or B, depending on atmospheric pressure. When the exhaust system is lean, less oxygen, is the voltage going to be high or low on an oxygen sensor? Now, you guys have been used to looking at fuel trims a lot, because I'm always sending you to look at fuel trims. But what about your oxygen sensors? Are they going to be read low voltage lean or high voltage lean? Lean is low voltage. Lean is low voltage. Remember that. Lean is low voltage on a zirconia oxygen sensor. The reason they said that was because every now and then, almost very, very few vehicles will run into a titanium oxygen sensor and it works the opposite. And that's sort of a screwball. But the long and the short of it is, you got zirconia oxygen sensor here, is what you're talking about. And zirconia is basically the ceramic bulb that's in the oxygen sensor, and it's a kind of an electrolyte. And it's comparing the oxygen in the atmosphere to what's in the exhaust, and it's calibrated so that electrons begin to flow. You know, it creates voltage, basically, is what it does. Where is Bank 1 Sensor 1 located on a V-type engine?
In the exhaust manifold?
Well, that is not a terrible answer,
A and B.
but it's not the total answer. Yeah, it's A and B. It's always going to be on the same bank where the cylinder number 1 is located. So the exhaust manifold is not a bad answer, it's just not the total answer. That's what messes me up sometimes if I'm taking a test and I'm machine gunning them. If there are 2 right answers, I'll answer one of the right answers and get that question wrong. A high O2 sensor voltage could be caused by what?
A and C.
Okay. How would a defective spark plug wire cause
I
it?
meant rich exhaust.
Huh?
I meant just rich exhaust.
Well, think about this now. If the spark plug's not firing, the oxygen's not being used either, and what's the oxygen sensor smelling?
Oxygen.
So it's not going to see the fuel. The oxygen sensor is not even looking at fuel. Oxygen sensor sees an absence of oxygen. If you see oxygen in there, it's going to basically show a lean exhaust initially whenever you start, when a spark plug misfires. That'll confuse you if you're not careful. Just remember that the oxygen sensor is smelling oxygen. Key word, oxygen, right? Okay. So that's going to be A only, right? A low O2S voltage could be caused by what? Wait a minute, did I just say that? Oh yeah, a low O2, that's the second question, which is the inverse. A low O2S voltage could be caused by what?
Lean exhaust.
Both B and C. See where I'm going with that? See how easy it would be to get those wrong? If you know that, it won't be a problem. An oxygen sensor is being tested using a digital storage oscilloscope. A good oxygen sensor should display how many switches per second? 1 to 5. Switches meaning from rich to lean, above and below a half a volt if you're looking at the old scale. Number 7, a P0133 diagnostic trouble code is being discussed. Technician A says a defective heater circuit could be the cause. Technician B says a contaminated sensor could be the cause. Which technician is correct? That is C. Now I'll pause for just a second and tell you this. I've talked about this before. All right. So what we have here, coming from there'll be power coming in. And we're just going to draw an oxygen sensor here. Okay. And then right here we've got a ground coming from the PCM. This is typically the way this is wired up. All right, now we've also got 2 other wires going to the PCM. All of these go to the PCM. This is going to be your signal, and this is going to be your ground, your reference ground. Now, this particular one right here is also a ground, but it is delivered to the sensor by the PCM. The PCM, believe it or not, is measuring how many milliamps that oxygen sensor is pulling. Okay, let's say you had an oxygen sensor here that was, and you got your connector plugged in, you know, right here's your oxygen sensor, right here. Okay, and you're getting a heater code. You're getting a heater code, right? Okay, so I got this heater code. And so what I'm going to do to determine what that is, I've got another oxygen sensor I have whacked the connector off of. And I'm going to hook up to these two wires. These will be the wires that are the same color, whether they're two brown ones, two white ones, two black ones, they all go to the heater. A couple of ways you can check it. Let's say I measured the ohms of the two wires. They're supposed to be like 5 to 8 ohms or something like that. And if you measure that and it's good, then you need to be looking somewhere else for your heater code issue, right? Well, I'm going to put a light bulb in here, like a fairly low impedance light bulb, you know. And I'm going to put it so that, plug that in. I've actually taken and I've cut the oxygen sensor connector off an old oxygen sensor that will plug right in there. Between the two wires that are same color, plug it in, fire it up, that light comes on. I know I'm, you know, got everything I ought to have. If I don't see a light, now I'm going to be looking for a broken wire here, some no voltage here, or something going on in there with in the PCM. So that's basically, if you go after an oxygen sensor heater code, that's a little quickie. How you can figure that out. That's something I came up with a long time ago, because I was seeing them sometimes that wouldn't have a bad oxygen sensor, but they'd have a heater code. You got me? Just changing a part is not going to fix every code, is it? How many of you run into that? You see a code, change a part, it didn't fix it. You've done that before, right? All right now. Let's see. Technician A says an oxygen sensor produces a voltage output signal based on the oxygen content of the exhaust stream. Technician B says if the exhaust has little oxygen, the voltage of the oxygen sensor will be close to 0 volts. Technician A right? Yes or no? Somebody tell me. He is, but the other guy's wrong because he's actually backwards. You're going to have a higher voltage. The other, I mean, if you've got, if it's rich, you know, if there's not much oxygen, it'll mean it's rich and it's going to read higher volts. Oxygen sensor cross counts can only be determined using what? Basically, you can only determine them using a scan tool. We really don't, I mean, you know, like typically you don't know what the time frame is. I guess you could probably do it with a scope if you knew what the time frame was that you were looking for. But that's how many times it goes back and forth within a given amount of time. And it'll give you actually a SPID that says cross counts on the oxygen sensor. Oxygen sensors get lazy, okay? Sometimes when you got a lot of miles and use on an oxygen sensor, and some oxygen sensors last the life of the car, never need to be replaced. But if you got one that's drifting around that's kind of lazy, it'll make stupid things happen, you know. Which of the following describes acceptable oxygen sensor cross counts? That's number 10. That is 8 to 10 at 2,000 RPM. Now, when you go to 2,000 RPM, you're going to get faster switching than you are idling. So if you want to see if that oxygen sensor is capable of doing things, let's go ahead and get it above the idle. A P0131 diagnostic trouble code is being discussed. Technician A says an exhaust leak upstream of the HO2S oxygen sensor could be the cause. Technician B says an extremely rich air fuel mixture could be the cause. Who's correct about that? A is correct about that. And what the deal is there, there's natural low pressure pulses that go through an exhaust system. And if you've got an exhaust leak upstream, and depending on which way the crack's pointed, whatever way it's cracked or loose or whatever, it can actually pull air in upstream of the oxygen sensor and fool the engine controller into thinking it's running leaner than it is. And what's that going to do? It's going to say, it's going to put more fuel in it. So it's going to drive the fuel trim numbers positive if you have an oxygen sensor that's downstream of an exhaust leak. So, and you know, a lot of times you feel like, well, it's just an exhaust leak, and it's not always puffing out. It's also drawing some fresh air in. A P0132 diagnostic trouble code is being discussed. Technician A says a defective oxygen sensor could be the cause. Technician B says an oxygen sensor signal wire shorted to ground could be the cause. Which technician? The only guy that's right about that is going to be the guy that's A. I will tell you that on these Chrysler vehicles, I have seen those things hang up at about 0.6 of a volt. the engine controller starts jacking the fuel trim around trying to get it to go below 0.6 of a volt, and it'll start bucking and jumping like a bucking bronco until it clicks into open loop, and then it'll clear up. If you got one that's puffing black smoke and you stand on it good and hard and force it into open loop and it cleans up his act for just a minute and then it starts blowing black smoke again, you got to figure that either your oxygen sensor signal wire is shorted to ground, you got a loose connection like a loose pin in there, or something like that. Because if it's trying to use the oxygen sensor to determine what to do with the fuel and it's being told a lie, like if it's reading lean and running rich, that's when the cat's on the roof. An oxygen sensor ground, let's say that you've got a 0 to 1 volt zirconia oxygen sensor, you measure in there with your meter and you're seeing like 2.5 volts. I'm thinking oxygen sensor ground when I start seeing a high voltage like that on the signal wire. All right. A wide band oxygen sensor was first used on a Honda in what model year?
96.
92 actually. A wide band oxygen sensor is capable of detecting air fuel mixture in the exhaust from what to what is the way of rich to lean.
B.
That's going to be C, 12 to 1, 15 to 1.
So what?
I meant 10 to 1 to 23 to 1. I don't know why I said 12 to 1 to 15 to 1. 10 to 1 to 23 to 1. A wide band oxygen sensor and a conventional zirconia oxygen sensor can be made with what designs? Now we hit some of these the other day on our emissions, but it's a good idea to burn this stuff in, right?
C.
That's going to be D. That's going to be cup and planar. Okay. Let's see. A wide band oxygen sensor can be made. Excuse me. Yeah. Wait a minute. That was 16 is where we're at now. A wide band oxygen sensor can be made using what design? Now, well, we've already done that. I don't know what I'm thinking about. It can draw how much current in ampere? The heater. How much? A wide band oxygen sensor.
15 is the same thing as 16.
15.
15 and 16 are the same answer.
Yeah, 16 is C. Yeah. Dual cell and single cell. Yeah, basically you can define them either way. What's a confusing thing when I'm just sitting here reading across these. Sorry about that. I sort of messed up on it. A wide band oxygen sensor heater can draw how much current in amps?
D, 16 C.
8 to 10 amps. 8 to 10 amps. That's a pretty good bit, isn't it? How much? Anybody got any idea how much current does a headlight bulb draw? One headlight bulb. We've done that before in here, right?
9 volts? No.
1500?
About 6 amps usually.
What?
So think about that. This heater is drawing almost, well, actually more current than a headlight bulb. A wide band oxygen sensor needs to be heated to what operating temperature?
2000.
1400. 1400 is where you're headed with that one. The two internal chambers of a dual cell wide band oxygen sensor are what?
D.
Air reference and diffusion. That's A. When the exhaust is rich, the powertrain control module applies what kind of current into the pump cell? That's B. Negative current into the pump cell. When the exhaust is lean, you can figure that one out, can't you? It supplies what kind of current into the pump cell? It's going to be positive if it's negative the other way, isn't it? Does the word duh come to mind? Okay. A dual cell wideband oxygen sensor can be tested using what? Voltmeter, scan tool, scope, or all of the above. Let's do all of the above. In some hybrid electric vehicles, the wideband oxygen sensor can cause the PCM to enter closed loop when? As soon as it starts, by the time it reaches 60, within 2 minutes, within 10 minutes of engine startup. That's A, instantly. Let me tell you a brief little story. This is a brief story. I had some equipment hooked up to a Thunderbird one time I was working on that had, two upstream oxygen sensors. And I was noticing as I was watching my equipment that the oxygen sensor on the left was reading really, really rich, and the oxygen sensor on the right was reading really, really lean. And it just kept shoving them in opposite directions. And I got to thinking about that, and I figured out what was wrong with it. The yo-yo that put the engine in it plugged the oxygen sensors in backwards. He plugged the right one into the left harness and the left one into the right harness, and it's like Ma and Pa having an electric blanket, and they get the controls crossed, and she keeps turning hers up and he keeps turning his down, and he's burning up and she's freezing. And what I'm saying is pay attention to that. If they're hanging close to one another in whatever car you're working on and somebody crisscrosses them, the only way you can tell a lot of times is looking at the wire color in your schematic, see which one goes to the passenger side, which one goes to the driver's side, right? Left and right. And whenever in a car you're talking left and right, that's sitting in the seat. When you're sitting in the seat, the driver's side is the left side, passenger side's the right side. And if it says it's in the, you know, sometimes you'll get the bulkhead, which is the firewall we used to call it. The passenger side of that, is going to be the part behind the firewall. That doesn't mean the right side, you know. To be careful with that, all of them things. I don't know where I got off on that for. Okay, let's see, what number are we on? Y'all help me.
24.
A conventional oxygen sensor has a reading of 900 millivolts on a multimeter. Does this indicate what? What does it indicate? A vacuum leak, lean exhaust, rich exhaust, or none of the above?
Lean.
Actually, the high voltage is rich, low voltage is lean. Do a little memory bug here. Lean is low. You remember that? Low voltage is lean. Just remember that.
900 millivolts was low.
Huh?
I thought 900 millivolts was low.
Well, 900 millivolts is actually almost 1,000 millivolts, which is almost 1 volt, which is the top of the scale. So you're basically, if you break a volt down into 1,000 volts, 900 is really close to a volt. A conventional oxygen sensor heater keeps the sensor at about
1400.
Nope. Actually, that's the wideband, 600 degrees. Back in the early days when they first started putting oxygen sensors on cars in 75, I think it was Volvo or somebody that used an oxygen sensor first, they were depending on the exhaust heat to keep the oxygen sensor hot, and they did it that way up until about 1982, and then they started putting heaters in them. Some of them went a little beyond that before they put heaters in them. All right, one advantage of a planar type oxygen sensor is A, faster light off time, B, it takes more than 2 minutes to light off, C, it only uses one electrode, or D, it can be color coded for different vehicles. That's actually A. What they're wanting is they want this thing to go into closed loop just as soon as it possibly can, right?
So here's the question.
Yep.
So what is a low reading for an oxygen sensor?
It would be down around 200 millivolts or
Oh,
below,
okay.
yeah, something like that. So down close to zero. Now the 500 millivolts is what it's switching on both sides of. So that's the mid range, you know. When it's every time it hits a half a volt, you're at 14.7 to 1 if the sensor's telling the truth. You got it? And 14.7 to 1. But now they actually tweak the, you know, nowadays the engine controllers are tweaking the fuel mixture above and below 14.7 to 1 as situations demand it, you know. Let me see. Here we go. This is a cool question. When the air-fuel ratio is expressed as a lambda, and you'll see that on your scan tool PID, so pay attention. A lambda number of less than 1 indicates what kind of exhaust, rich, cold, hot, or lean. It's not going to be cold or hot. Less than 1
Be lean.
is going to be actually rich, believe it or not. It seems to me like that was a screwed up backwards thing. I'm like you. Low voltage should be lean, but when you're talking lambda, when you go below 1, you're going rich. When you go above 1, you're going lean. Got it? So lambda represents, lambda of 1 is 14.7 to 1. That's the perfect. If it's going below or above that, it'll be, remember, below 1 is rich and above 1 is lean.
So
But on voltage, it's the other way around. That's just, huh?
Is rich more fuel to
Yeah,
air?
more fuel to air mixture, that's right. More fuel than air. When it runs really rich, it'll blow black smoke and stuff like that. And if it's running a little rich, you get carbon monoxide, right? Technician A says a wideband oxygen sensor, also called a lean air fuel mixture, can detect air fuel ratios from 10 to 23, and we just hit that one a while ago. Technician B says oxygen sensor signal determines fuel trim, which is used to tailor air fuel mixture for the catalytic converter. And that's basically, both of those guys are right, you know that. Basically, you're trying to get the cleanest burn you possibly can. Unless you've been standing, have you ever been driving along behind a car, or like you've got your AC on just norm instead of max? You're driving along with norm AC, and you got air coming in through the vents and all this kind of stuff. And you come up behind a pickup truck or something that's a really, really old one, and all of a sudden you start smelling gas and it's burning your eyes and all that kind of stuff. You ever had that? I mean, I had it the other day. I was behind a pickup truck that was driving along, you know, and there's a lot of, you know, you could tell that smelly exhaust was coming through there. Well, there was a time when every car had smelly exhaust. It was terrible. You know, when I first started working on cars, but there wasn't no catalytic converters and all this kind of stuff. All right, let me see here. Let me see, number 29. On a poorly running engine, a wideband oxygen sensor can be quickly checked by doing what? That's a good question, isn't it?
Disconnecting the sensor connector.
Yeah, that's smart. Disconnect the sensor connector. Conventional oxygen sensor heater uses about how many amps? Label not 0.8 to 2.0. That ain't very much. That's a far cry from 8 to 10, isn't it? Which is the other one. If the air fuel ratio is 14.7 to 1, what's the lambda value?
B.
That's going to be 1, isn't it? If the lambda is 0.98, that means what?
It's slightly rich.
Slightly rich. There you go. Good answer. Base pulse width is determined by, ooh, that's a good question, isn't it? Not the O2 sensor. Input from other sensors. Base pulse width is determined on input from other sensors. You got to understand how that works. You got a crank sensor that's telling the injectors how often to click, right? Now that click, that pulse width, when it does click, how long it stays open, is directly correlated to how much fuel it's delivering. If the engine coolant is cold, if the intake air is cold, if the throttle position sensor is at wide open throttle, if you're under a heavy load, you're going to broaden that pulse width. If you're at wide open throttle, you typically, on most vehicles, just about all of them, except the some really cutting edge new stuff, you're basically going to drop into open loop, and you're not going to pay attention to the oxygen sensor. So anyway, that's the thing there. You're breaking that loop. Let's say what is not true about short fuel trims?
B.
What do you think? B is actually that it can abstract or subtract, add or subtract a large amount of fuel. It can't. It basically is making real fine adjustments. Long fuel trim's like a coarse adjustment. Short fuel trim's like a fine adjustment. Fuel trim provides a method that's capable of changing the amount of fuel delivered to the engine based on feedback from which input sensors. That is a no-brainer answer. Everybody better be saying oxygen sensor or slap yourself. Technician A says the primary purpose of fuel trim is to keep the air-fuel mixture as close to 14.7 to 1 as possible, and B says when the air-fuel ratio is 14.7 to 1, the efficiency of the catalytic converter is the lowest.
Is that both?
That's actually going to be A. It's going to be if it's 14.7 to 1, the cat loves it. It's working really well. Technician A says air-fuel ratio lambda number is lower than 1.0 indicator lean mixture. He's wrong. Technician B says the air-fuel ratio number is higher than 1.0 indicator rich mixture. Both those guys are yo-yos. We're not going to go with them dudes. To determine the air-fuel ratio of lambda is given. Have you ever heard anybody when you're talking to them say something that you just knew was dead wrong? And they were just absolutely certain that they were dead right? You know what I'm saying? There was a guy one time years ago I was talking to when I was at Sambo's. I used to eat supper at Sambo's every night. And he would say, he said, if you take the thermostat out of a car, it'll overheat. And I said, what? I mean, that is absolutely backwards. And he says, no, I know better, you know, blah, blah, blah. Well, it turns out that if you line up 500 cars and you put one out there that's got a really little bitty radiator and you take a thermostat out, it'll overheat. But every other one of those 500 cars is going to run cold as a post if you take a thermostat out. You know, and anyway, it blows me away how some people can get that cemented into their mind. To determine the air-fuel ratio, if lambda is given, multiply lambda times what? Ooh, a math thing, 14.7. That good answer? The equivalence ratio, ER, is blank lambda. Which one of those? Same as, higher than, 5% higher, 5% lower, or the inverse of? The inverse of. And a lambda of 0.97 means the engine is operating what percent rich and has a mixture of what to 1. That's going to require you to do a little math, isn't it? Let's go with 3% rich and 14.3 to 1. Now, give me half a second. And I'm gonna